Neo, we don't have much time. We've brought the Nebuchadnezzar up to transmission depth to provide you with some final instructions before Thursday's AP Physics 1 exam. This is your final mission brief. Neo, these are your enemies. They have been planning all year. You will defeat them on Thursday. As previously discussed, there will be two questions: a qualitative-quantitative translation and a paragraph argument short response. The details are found here, and I shall discuss more with you as we continue. Units that are fair game, no change from what was previously briefed. Electrostatics and waves will not be on Thursday's exam. Neo, we've made a decision. The prudent student will type their responses on exam day. This is the leading recommendation of those in the AP Physics community. There is no need for any special text like there are in the calculus and chemistry tests. The readers have communicated to us that they will understand your intent if you type logically those equations that are necessary, examples provided here. Neo, do not use an equation editor. If you attempt to upload an equation editor into the format on exam day, it will not be uploaded. Question 1, qualitative-quantitative translation. Our advice: read carefully, don't skim. Ask yourself the why of the question. Why am I being asked this question? Don't rely on your reflexes. They'll let you down 50% of the time. Answer the question asked. Don't answer a question you weren't asked. Use multiple representations. Describe the process. Describe the answer in as many possible ways as you can. It may seem repetitive to you. It's what the readers are expecting. Use words, use equations. Attack the problem from every perspective. Think through using claim evidence reasoning. It's an outstanding format. If you think the question was too easy on exam day, you're doing it wrong. When you answer the question, tell them what you're going to tell them. Tell them this is a Newton's second law problem. Tell them the answer they're seeking. Then tell them what you told them. It will feel repetitive. They're looking for your demonstration of mastery. Do not assume that they will understand. If you feel like you're saying the same thing multiple times, you're probably doing it right. When they ask how does part A relate to part B, tell them how it relates. Qualitatively, quantitatively, in words, in numbers. Compare, contrast. Bring all relevant principles to bear. Nothing beyond what was asked, however. When ranking, which is greater, which is least, solve first, and then answer. If you get stuck, press on. Perhaps as you go further in the problem, a neuron will fire. If you get stuck, if you need an answer for part A to answer part B and you do not know, assume a value for part A. Tell the readers you're assuming a value. and press on. You cannot, however, assume a value for the answer. You cannot say, I assume a value for part A, so I assume an answer for part B. Organize as on the exam. If it says part A, write part A, your answer. Part B, your answer. Label your sections. Do not fall for traps. You've seen this problem before. Analyze the problem. Don't make assumptions because it's going in a circle, it's uniform circular motion. Don't make an assumption because it looks like a pendulum, you need the pendulum equation. Analyze the question. Avoid your reflexes. This is not math class. This is physics. For paragraph length response, the readers are looking for a paragraph. They don't want to see bullets. Answer the question. You can place equations inside the body. Don't focus on the answer initially. Focus on all the relevant information in the question. Then apply basic physics principles to the information. Cite all relevant principles and their relationship. If you finish early, you've done it wrong. Same process. Tell them, tell them, tell them. Think through your claim, evidence, and reasoning. And when you finish, identify your conclusion. Make it clear, this is what I have concluded. Neil, you're likely to see something you've never seen before. That's okay. Several years ago, we were confronted with a problem of an inclined plane with evenly spaced bumps to determine if the object moved at constant velocity. Bring your physics principles to bear. You will see much that you've never seen before, that we've never thought of before. That's their job, to test your ability to apply physics, not to repeat an answer that you've memorized. Key terms. I will email you this slide deck. But when you come across the terms, understand what the readers are asking you for. Your exam will run as shown. Check-in, 25 minutes for the first question, 5 minutes to upload your response, 15 minutes for the second question, 5 minutes to upload your response. Do not attempt to extend your time. You risk being locked out of the system, and there is no opportunity to re-enter the system once you're locked out. Between now and then, test your equipment. Try the test demo with the link shown. If the test demo does not work, you will not be able to test on exam day. Review. Go through the FRQ keys, the videos we've created. My recommendation is to stay with the flipping physics, review, and work free response questions with the link shown. Write notes to yourself of specific concepts. Annotate your equation sheet. Watch our daily Zoom sessions. The schedule. Some may conflict with other exams. We will record these sessions. If you can send me specific questions you have 1 hour before the session, we will work those problems. Neo, we will be ready. I invite you to send me any questions you may have. We're told that sentinels are approaching. We must return to Zion. We will return to transmission depth shortly.